in this presentation, we are going to mostly work over creating a VNF from scratch, okay, following a guide. But before that, would like to give some visibility to a group I'm leading in the community, in the OSM community, which is called the VNF Onboarding Task Force. In this group, is a formal group of OSM. We have a vision, an objective, which is to achieve more VNFs in the market that are completely onboarded. And when I say completely onboarded, is VNFs that have packages that completely model their characteristics, but also their operations. So it would be, in OSM, it would be packages that contain the descriptors, that contain the charms they need, that contain all the monitoring, auto scaling, and everything that the VNF needs for instantiation and up-to-date to operations. And that gives an opportunity to simplify the industry and having unique VNF packages per function. Not a lot of versions of the same thing. It's just would be a unique package that works seamlessly across any infrastructure, independently of if it's a public cloud, if it's OpenStack, if it's VMware. It should take care of launching the VNF, making it manageable. That would be what we call a zero, right? So VNFs are already there. Then the orchestrator should configure the VNF so that it provides the expected services, and then orchestrator should, or the generic VNF manager should monitor, should operate this service in a closed loop. So this is the vision we want to fulfill with VNF packages. In this group, last year we published the ONF VNF onboarding guidelines, which is a document that explains how to onboard a VNF in open source MANO. So it talks about the onboarding requirements whenever you have a VNF, what you need to gather as requirements to be ready for onboarding. And then not only initial requirements regarding resources, but also for day 0, for day 1 operations, for day 2 operations. What would you typically need to gather from the function so that you have everything, every information you need to create the package? And then you have the specific instructions for specific days, we would say. For day 0, which is mostly addressed with, for example, cloud init, and as well as the rest of the package, you have to create the package and give it some structure and addressing, take care of the instantiation parameters, and finally provide some basic configuration so that that VNF can be manageable. In day 1, you have to know what to, well, you already collected what you wanted to configure in the VNF. So now in this guide, you can learn how to apply this configuration using charms. So this is written for the, what we would say, legacy framework of UU charms, which would be the reactive framework. I know you learned today about the new Python operators framework. So this guide will definitely migrate to that. But anyway, a part of the contents or how the charm is built, your final product for achieving day 1 is a charm that you use to apply certain configurations to your VNF. And then you have day 2. In day 2, you have on-demand operations, on-demand configuration that you want to apply. I've put also here auto-scaling operations, for example, and monitoring. So that's what we prepared as a guide for VNF vendors to know how to prepare a package in OSM. And also there is a session well, there's a document that is called the VNF Onboarding Walkthrough, which uses open source packet core provided by Netscape EPC. Well, now it's called Open5ES. And it goes through applying all the instructions from the onboarding guide to a specific VNF, so that you know you have a reference to apply it to your own examples. So there is a video on this walkthrough, and of course the documentation. So this is the walkthrough that I would like us to work on today. I mean, to build a VNF from scratch. I have updated the guide a little bit compared to the original video, so that it's more current to the new release. And then, before jumping into the hands-on, we have the Onboarding Labs as an extra resource in the VNF Onboarding Task Force. These Onboarding Labs are hosted by Etsy in the same beam that you're working, where you worked yesterday and the first day. Is an OpenStack platform with some compute resources and tools, and there is an OSM, a generic OSM installation, a single VM, just like the single VM you used yesterday, but this is dedicated for VNF providers, so that they can, well, first of all, they get access to Etsy Hive network, and then we give them a tenant in OSM and a tenant in OpenStack, so that they can onboard, work on the onboarding of their VNF, and they have the assistance from the group, from the VNF Onboarding Task Force. So this gives them a secure environment to test and their software with OSM. So if you know of any VNF vendor interested in obtaining access to these labs, is free, and they just need to reach us at our mailing address or Slack channel or through Etsy. There is something else that is upcoming that is very related to what the VNF Onboarding Task Force wants to do, which is a feature called the OSM VNF Repositories. This feature is basically giving a structure for hosting repositories that contain VNFs, and also gives tools in OSM client to consume from these repositories. So imagine that you host you're a VNF vendor, and you have a VNF, and you want to share it with your customers that are operators that are interested on or are using OSM. So we want to move away from sharing the VNF package through email or any drive, and with its corresponding license, and maybe lose track of the versions of that VNF and things like that. We want to automate that process. So VNF vendors with this feature would be able to build just a web server that hosts a folder for the VNF in a way that OSM would understand that folder. And of course, there is a link to access that repo. That can be public, can be private, it depends. Maybe you need a VPN to access for it, it depends. The thing is that you would need OSM client to reach it, and you would be able to add that repo to your local environment and instantiate a VNF directly from there. So you can instantiate, and OSM will automatically add it to the catalog and then try instantiation. So that's the objective. This feature would will be ready for the next release, and will definitely bring more opportunities or increase the possibilities of having more and more VNFs onboarded in OSM, so that operators consuming OSM as a product in their networks will have access to a marketplace of network functions, which at the end is fulfilling the NFV vision. We will follow the guide that I mentioned. Just this slide that details what we are going to do. If you already use Visual Studio or a similar tool like Sublime or Atom or Notepad, I think there's a Notepad++ or something like that in Windows, use it, because that will accelerate the building of your VNF. And Visual Studio is the one we recommend because it also includes a package for linting for OSM. I mean, while you are working in the descriptors, it throws you hints about if it's following the model or not. So I'm specifying this now and not before, because I've seen people struggling with new tools during Hackfest instead of focusing on the exercise. So I would prefer to recommend whatever you use to feel comfortable at editing files. If it's copying the contents from Linux, pasting it into a notepad and editing from there, that's fine. Whatever you feel more comfortable with, okay? But well, in the worst case, you will have to use Nano or Vim in the same machine, I mean, in the Linux machine of OSM. The EPA section, we will skip it, okay? So everything that is related to SRAOV and the guest EPA, like CPU pinning and everything, that we are going to skip it. I mean, it's documented, it's very simple, but we're going to skip it because when we instantiate, and if everyone achieves to get an instantiation, we will have enough resources at this lab to cover a high performance for everybody. So let's skip the API section. And for charms, as I said before, we'll use the traditional reactive framework, which is still valid in this release, and the migration to the Python operators framework will happen eventually in this documentation. So a brief introduction to what you are doing today. This is the walkthrough documentation. All the results are here. I mean, the resulting packages, the images, and a video presentation. So we are building these packages from scratch. So try not to download them, or if you are running out of time, then you are welcome to download them and test them. But they have changed a little bit. I have to update here the packages. So if you are using the resulting packages as a base, just compare the packages with the rest of the content of the documentation, okay? First of all, you start here with VNF requirements, because the first step to onboarding a VNF successfully is to gather the requirements. It's documented here, and here it is applied to a VNF. So this VNF is built from 2 VDUs. It's a single VNF with 2 VMs. It's a simplified version of a packet core because it collapses a few functions. For example, the S gateway, the P gateway, the MME are collapsed in a single VDU. And this is the image here for that. And this image is uploaded into the Vim already. We have the HSS, which is a separate VDU. And what we are doing with this VNF is launching it as day one configuration. We are integrating both components together. And the requirements also include the characteristics of the VDU. We are not asking for much. This is just an example. And there are some API features for the data plane, which would be the S1 interface and the SGI interface of the packet core. They require performance, so we are putting CPU pinning, huge pages, and SROB there. But just in this particular experience, we will jump that because we don't have enough resources. This is the topology of the VNF. So whenever you want to build a VNF, you have to have some sort of topology to know the connection points, how they interact together. As you can see here, we have two VDUs that are interconnected by an internal VL, internal virtual link. So this is in the responsibility of the vendor, as you can remember. And then the VNF exposes a few connection points for integrating to the external world. So we are exposing management for both VDUs. We are exposing an S1 interface, which is for those who are not related with how a mobile packet core works. The S1 interface is the one facing the users, the smartphones, if you want, the Node Bs. And the SGI interface is the one facing internet or whatever network we want to reach. So the data flows through S1 and SGI, and the S6A is the interface for managing subscribers, because subscribers database is the main function of HSS. So this is, as I said, a simplified version of a mobile packet core. Then we want to decide how we are going to initialize this, the configuration of these VDUs, so to make them manageable. So for this, we will use Cloud Init in its simplest form. We are providing a parameterized password, which we will feed during instantiation. Okay. So in this experience, you are going to learn how to work with instantiation parameters, which can be fed at instantiation time. So we just put a password, which is a password with double brackets, and it will be filled in later. So these are it's part of the design of the VNF to have the cloud init files ready. Then day one. So we already covered day 4 requirements with the images that we are going to use, the resources that the VMs are going to consume, and the topology that the VNF has, and also how we are going to achieve management. We are going to set a password in this case. Day 1 is all about configuring the VNF for it to provide the services it needs to provide to users. So we would need, in this particular case, to enable some interfaces in the SP gateway, enable some interfaces that are down by default. We would need to access the system and also replace some configurations to feed the system with the HSS IP address and its own SP gateway IP address, so it knows where to start the service and where to connect to the HSS. Okay, so there's simple ways of replacing the configuration file with a parameter, which would be fed later. And finally, we would need to restart the MME daemon so that it takes this configuration that we are passing. So this is the day 1 operations that we are including in this example. Of course, in a real world packet core, it will include more things than this, but we are just providing a few things for you to learn the idea. And then the HSS is, well, it would need to enable a second interface, and we would need to replace some IP addresses in the HSS configuration, so its own IP addresses to know where to start its own service. and the SP gateway IP address to know where to integrate to, and then restart the service. So that's the day one requirements that we have included in this example. And we will see how to implement them. Then day two requirements, well, the simplest example we thought of it would is to add a route, a static route, to reach some destination through the SGI. So we can feed the system with a prefix and a next hop, so that dynamically I can add new routes to reach different systems from this SP gateway. Okay, and as day two also, I'm including some metric collection through the BIM, so that we get some hypervisor stats regarding CPU and memory. So those are the requirements. So here we gather the requirements for day 0, day 1, and day 2. We know how to instantiate our VNF. We know how to manage it as part of day 0. We know what we want to configure on the VNF, so for it to start the main services, and we know what we would like to do next when it's already instantiated, what we would like to do on demand. Okay. Perfect. So after we have reviewed this, the real work starts here, building the VNF package for day 0. So you have to enter your instance of OSM, the one we used yesterday, and create a package with a base package. This is a tool of OSM for creating a base package with some characteristics and giving it a name, and it will be located at a specific directory. Then we will replace some values, interfaces. We'll modify some names so that we know which interface does what. We will, in the second VDU, because we have 2 VDUs, well, we will need to add a second VDU with 2 interfaces, and this is, you can just copy and paste this, but you need to paste this in the right place. You know, underneath VDU, you already have the first VDU here, and you will add a second one underneath it. Then we would modify the S6A connection point to be an internal one, because by default all connection points are external. So this interface here between both VMs need to be converted to internal one. So then Ethernet 3 would change to being internal and having an internal connection point reference, which is specified underneath. And we will have another in the HSS. And finally, we will have the virtual link that interconnects both at the global level of the VNF. Then we'll modify some connection point names that we changed before, and this management interface for OSM to know where to go to manage the SP gateway. And we will set some particular subnets because as a VNF vendor, suppose that we want to specify IP addressing, a particular IP addressing between both VDUs. So we will use IP profiles for that, which give the possibility of modifying the subnets and apply it to the VLD. We will skip these EPA requirements, and we will apply the cloud init files that we should have created in the cloud init folder. And then we will validate the package. So that's the first thing we are going to do. I hope we reach this point at least, and then so we can continue with day 1 and day 2. Okay, so I will start. In my case, I like to use Sublime, so I will use that. But first, I will create my package, just as it says there, create a folder. So at this path, I should have the YAML. There it is. And I use a remote Sublime for editing. So I can edit it using this tool, which is easier. So I highly recommend you to get familiar with one of these tools if you're interested in onboarding, because it's easier to edit the YAMLs. So I'm going to edit my YAML, which is this. If you are following me, I'm editing the VNF YAML. First thing I'm going to do is change the name of the VDU, because it's a generic name. VDU is called EPC, so I'm changing that to SP Gateway MAB, and I'm changing the connection point names. Changing the connection point names so that they make sense. I have the management interface. This is a good practice. You don't use generic names, but meaningful names for your connection points, so that we know what we are connecting to what. Okay, I'm done with this step. Now they ask me to add a second VDU. I will just copy and paste this in the right place. So it should be at the same hierarchy as SP Gateway MME, and it's already completed with the connection point names and the VDU name. I will then modify the connection point which interconnects both, which is Ethernet 3 in the case of the SP Gateway MME. I will put it internal, and change it to internal connection point reference. So since I have an internal connection point, I need to include that connection point at the VDU. And this is the port modeling. I mean the connection point modeling. Same thing for the HSS. Ethernet 1 migrates to internal, and the connection point needs to be exposed internally from the VDU to the VNF. So it's named HSS S6A. And finally, the virtual link that unifies both is globally defined, and you can see it connects SP Gateway MME with HSS at interface S6A. These are just names of the connection points. So I'm done with this. Okay. Then what else? I need to modify the connection point names that I previously specified. So the connection points that are exposed to the network service. So we have internal connection points that are exposed from the VDU to the VNF to connect them through an internal virtual link. And we have the external connection points that are just exposed to the network service, and they are connected to elements as specified in the network service descriptor, not here. And we also need to take care to ensure that the management interface, the global management interface of this VNF is set to something. So this is already here. I will just change it. So just change it, don't duplicate it, because you will have problems. Just change the management interface. I'm not speaking that loud because I know many of you are following this at different rhythms, and so no one to interrupt. Then I will set a specific subnet prefix for our internal VLD. We'll put it here. The order doesn't matter. And this profile name needs to be put in the internal VLD so that elements in the internal VLD get this addressing. The APA section, I'm going to skip it as we agreed. So be sure that you're skipping that. And finally, I'm adding this cloud init file attributes that refer to a file that must exist at my package. So in the SP Gateway MME, I'm adding a cloud init file for SP Gateway MME. And for HSS, I'm adding a file accordingly for HSS. Let's put it here. Now I need to create those files inside this folder. So I'm going to go back to my machine. There's no such file or directory. So let's create it. Oh, okay. Oh, sorry, it's VNF. There's a mistake here because the folder is VNF, not VNFP. So I'm going inside it, and in there I'm creating a cloud configuration, removing that one and creating a new one. For this, I will just use Vim. Vim, and the name of the init file is this. And we'll copy the contents that we defined at the design stage. Sets a host name and a password. Okay. Now, HSS, it has its own init file, similar but with a different host name. I guess my package is ready for day 0. Now I need to validate it. So at the home directory, validating, okay, it's valid. Building the package for day 1. So first of all, we need to make sure that the management interface was set as SP Gateway Management. I mean, the connection point was set correctly. That's important. I'm going to open my scripter again. So this here, management interface, CP, and the SP Gateway MME management, is important to tell OSM to reach the SP Gateway through its Ethernet 0. Make sure you don't duplicate this parameter because it can cause some problems. Okay, so it says to add the VNF configuration part. This is done when you apply a charm, when you want to use a charm that is built already. You probably saw this during the morning session. You need to consume it by using this in the descriptor, charm, SP Gateway charm. This would be the name of the charm we are preparing. And the primitives it will run. So whenever we find initial config primitives, it's about actions that OSM will take over the VNF automatically without us doing anything. So that's the one. So VNF configuration is a global block that can go at any place. Right here. It first of all provides the user and password and the IP address. This is automatically populated by OSM. And this is the username, and this password we will provide it at installation time. And it's the same password that we are setting at Cloud Init. So we tackle both sides. Tell the VM what password to use, and we are telling OSM to access the VNF using that password. Then we are configuring the SP gateway, providing some parameters, the SP gateway IP, the HSS IP. And then we are restarting the SP gateway. And for that, we are using the SP gateway charm. Pretty straightforward. So now we are doing the same, but for the HSS. So since I already have a charm for the VNF that it's global to the VNF and applies to the global management interface, how do I apply a charm for one specific VDU? And this is what we wanted to show here, a way to add charms for specific VDUs. So, and we have the VDU configuration block, which is exactly the same as the VNF configuration block, but applies to a VDU. Here we go. So we have the same config primitive, and then we have configure HSS primitive, and then we have the restart HSS primitive, all of it in the HSS charm. That VDU configuration block is inside the VDU HSS. Okay, make sure that's inside and not as the VNF configuration block, which is global. How do I differentiate between one another? Is because the VNF configuration applies to the VDU that is exposing the management interface. I mean, we will say the global management interface for the VNF. And the VDU configuration applies to the VDU where the block resides, and we need to specify which of these ports is the management port. So for that, we have to put management interface true in interface that is the management port. We put it here. So with this, we are ready for day one at descriptor level. Now, we need to create a charm. But before that, I will validate the package just to cover any changes. Okay, it's valid. And now we will create a charm. So here we have to install the charm tools, but I guess it's already installed for everybody. So just running it, it's already installed. We need to create a layers folder where this is a practical way to put all the charms in the same place. There are other preferences of other users to put the charms in the VNF and then build them inside the VNF as well. But we're using this approach. And we are telling the system where the charms will be located. And we are telling the system where we are going to place the charms that we're going to design. Then we're going to enter that path, and there we're going to create the charms. So the first charm is SP gateway charm. Exists. Okay, I will remove it. I will remove everything. I'm going to create a charm, create it, and then I'm going inside the folder and start modifying the files. Some files I'm going to modify them using VI, others using Sublime. But the general idea here, and I think it's a similar approach in a Python operators framework. You need to you need to populate the charm with important things that will get OSM to access the VNF with the right packages and the right credentials and the right scripts that need to be run after an event occurs. It's only that Python operators framework is better built for event-driven configuration, while a reactive framework is may be a little bit more difficult to use. But if you follow these instructions, then you will have a general idea of the reactive framework and will be able to compare with the Python operator framework and notice the advantages of the new framework when you that you used this morning. Okay, so I'm going to delete all the contents that were there just to be sure that I'm including what I need. So layer basic and layer VNF proxy will include the packages or the files that the charm needs to access the VNF automatically using SSH. Then the metadata file is just information about the, I'm going to modify this in Sublime. Information about the charm. I'm pasting just the same thing that I have here. Then the actions YAML, the actions needs to contain the actions that we have at our descriptor with the parameters that we define at the descriptor. So we need to create that file, so actions.yaml. And we have configure SP gateway, providing the IP addressing, and restart SP gateway without parameters. Okay. Then we need, for each action, we need to create a file inside the actions folder. And this is just a requirement of the charm. You need to dig into the details, just something that it needs. So these need to be files that are executable, so make sure that you make them executable at the end. They all have the same content, and you just need to create a file for every action that you have. So if you copy and paste this, it will just do what we want. Inside the actions folder, it will create two files, both executable. So at the end, if we list actions, we will have two executable files with the same content, but one for each of the actions that we have at our actions channel. Finally, the most important file in the charm, in the reactive framework, is the reactive file. Inside the reactive folder, we add a file, well, that is already pre-populated, where we are putting the actual actions that we are running. So make sure that you include some of the dependencies that are not included usually by default. And then make sure you add both actions there. So configure SP gateway, what it does when it runs is gets the IP addresses that we provided at instantiation time, activates the interfaces, and modifies the MME configuration with the IP addresses that we need. And the restart SP gateway just restarts the process. So we are done with this charm, and I will continue in a similar way with the HSS charm. So going back to the layer path, a question: in the next release, the reactive is going to be replaced? As far as I know, there is no replacement expected, and if there's someone from Canonical here can confirm. But what I've heard is that both will be available in parallel. It's just that maybe you will notice some advantages progressively over time on using the Python operators framework versus using the reactive framework. It's just that. But both can be added. The final result is a charm, and both can be used by the OSM system without problems, and you as well. We'll support both ways of building the charms. Okay. Okay, so I'm building the HSS charm now. HSS charm. First, layer YAML. Then meta data. Then the actions file has configured HSS and restart HSS. Actions.yaml. Go. Then the actions folder. This is maybe the most repetitive part, creating the action folder and everything. So the new framework, there will be some efforts for enhancing usability so that we can learn to do these kind of things that are repetitive. So I need to have two files, one for each action, both executable. Perfect. And now, the most important file on the reactive framework is the reactive folder with the file, dependencies, replaced, and the actions that we want. So when configure HSS action is triggered, the IP addresses are get and replaced in the HSS conf, and the HSS is restarted when the restart HSS action is triggered. So we're done with the charms part of day one. Since we are already doing charms, we can proceed with the day two as well, and finally validate the package. So just as a recap, in this part we are creating the charms using the reactive framework, which is the previous framework that we had, and now we have the Python's operators framework, but both are valid ways to build charms. It's just that Python's operators framework brings more advantages for users, for developers. So with the reactive framework, what we need to do, well, with both frameworks, what we need to do is first to modify the descriptors so that we include the configuration logs and the primitives that will run automatically if we are talking about day one, and the charm that associated or that includes those primitives or actions. We can do it at the VNF level for the management, the VDU that is declared at the main management interface, and we can do it at the VDU level for any VDU. And you're required to have the management interface set as true in the interface, management interface of the VDU where you are adding a VDU configuration. Then, okay, we build the charms. So the charms contain some generic information about the layers that it will include. So the layers are code that is already ready to use. So accessing the VNF through SSH is something that is already available. The code is there. So is the layers that we're using. We have an Ansible layer, for example, as an alternative. And here we're building a new layer on top, which is the layer for our VNF specifically. For that, we need to build some metadata for that charm, the actions that we are going to run with the parameters that we need for each action. Then we need some generic files for each action we add with the same content all the time. And finally, the reactive file, which is where we set some dependencies and the actual actions, the code that will run associated to each action. So the code can be anything that we can run through SSH by default, and we send the command through methods of the charms library. Of course, we can use other methods here as REST API or Ansible. It depends on the layers that we include in our charm. Here we are using the default one, which is SSH. And we are doing so we're creating a charm for the ISP gateway, and we are creating a charm for the HSS. And that's it. For now, we created the charms, and they need to be built and copied into the package. But first of all, we will take care of day 2, which is some extra primitive and the charm, and then we will build. So in day 2, it's just a matter of adding the primitives that you want to run on demand, not automatically. So that's a new block that is called config primitive, not initial config primitive. And here we said that we would add a route. The primitive would be just adding static routes to the Linux machine. So we are providing the external prefix parameter and an xhop. But we can provide default values if we want, but we can provide a specific value every time. So I'm going to, again, go back to my home folder and modify my descriptor to include the primitive. We are doing that and the XP gateway. So we have a config primitive now, which, as compared to the initial config primitive, it doesn't run automatically. It runs whenever we want. So we trigger it. We just need to modify the actions YAML file so to add this new action into the charm. So I'm going back to the layer folder, the SP gateway charm, and modify the actions file. Now we're going to add the file that has always the same content. And the action itself in the reactive file. So the action itself, I'm going to add it here. It doesn't matter where you add it. So this action add route actually gets the parameters and adds a route using the Linux correspondent command. And that's it. After we are done with adding that primitive for day 2, we can build the charm. We can build both charms and copy them to the VNF folder. So for that, we get into the charm, you build it. Usually, we just need charm build, but since this is a shared machine, I've seen some challenges with privileges. So I've seen that with sudo, it works. I mean sudo and then -e, so we don't lose the environment variables. So the build charm is actually the one that you need to include in your charms folder. After the charm is built, just need to copy the result, which is by default in charms builds, and in your UU repository variable, and then the folder builds and the name of the charm. So you can copy that folder to your charms folder on your VNF. And then we will build the HSS charm. So the HSS charm is built, and now I'm copying the result to the package. So at the end, the package should have two folders inside the charms directory. One is HSS charm, the other one is SP Gateway charm. Finally, as part of the two operations, you would say, we can include monitoring params. So in this case, I'm specifying the monitoring of CPU and memory, the corresponding normalized values of the NFVI metrics. So this goes at the VDU level. VDU here. Be at the end of the SP Gateway VDU. And we need to refer to that globally, so that if we want to use scaling or alarming based on this, we can expose them with a global name at the VNF that can be put at the end. So I'm taking the VDU monitoring param from the given VDU and giving it a name. Finally, I'm validating the package again, and it's ready. Oops, there are errors. I'm glad to see this. So, not possible to determine the type of descriptor. There must be a problem in some way. Actions there. The SP Gateway charm is being validated somehow. Okay, it thinks, the validator thinks that the YAML files inside the charms folder are descriptors, but they are not. The only descriptor is the VNFD YAML. So I think we are okay, but I'm giving this feedback to the developer of the package validate, because this is a new command. It's not even available, I guess, in the latest version. We added it here. I would say it's the master version of OSM client, just to experiment with it and give some feedback. So this is good feedback, actually. Okay, so whenever you reach this, we are ready for instantiation. We will just need to create a network service package, and then create the VNF packages, compress everything, and instantiate. What we are doing in day 2 is adding a primitive that can be run on demand. So it's not an initial config primitive, it's a config primitive inside a VNF. This config primitive particular, we are during the design phase in the onboarding requirements of this particular example, we said that it would be a static route, adding a static route. So it has a parameter that is external prefix and the next hop. So for adding a primitive, we add it in the same VNF configuration block of the descriptor, and then we need to add it to the charm. To add it to the charm, we just add it as a regular primitive. So the UU charm, it doesn't care if it's a day 1 or day 2. It's on OSM to decide if it's going to be a day 1 or an initial config primitive, or a day 2 or a config primitive. More than that, you can use the same config primitive. You can use it for day 1 and day 2. So at the charm level is the same. You just add a new action. In this case, it's called add route with the parameters. You populate the corresponding file in the actions folder, and you add the code tied to the action in the reactive folder in the same file that we have, where we have all the actions. So it's just another action. Finally, what we did was to build the charms and copy the resulting build charm to the package in the charms folder for both SP Gateway and HSS. As part of day 2, we also included some monitoring in the descriptor. Many people would consider monitoring also part of day 2. So we thought about putting this content here, and it just goes and grabs metrics from the NFBI. I mean, from this means through the Vim. In particular, in OpenStack, it would be from Gnocchi. So CPU utilization and average memory utilization, and gives them an ID, which is then defined globally at the VNF level and given another name. In this case, we're giving it the same name. And we validated our package again. The final phase is to actually launch this VNF package. To test it, we will need also a NSD, a network service descriptor, so we can create it with the package create command as well in the same directory, but instead of putting VNF, we put NS. I'm doing that. Okay, it's there. Now, the contents of the YAML are here. So the network service is, as you should have noticed already, a collection of VNFs. In this case, it's just one VNF. And how these VNFs interconnect with each other. In this case, the VLDs, right? So the virtual link descriptors, we have 3 of them: the management network, the S1 network, and an SDI network. The management network is where the management ports connect. So the same VNF, but the 2 different BDUs at their management ports connect to this network. But in the S1, we have just 1 port from the SP Gateway MME BDU, the S1 connection point. And the SGI, we have the SGI connection point of the BDU, of the SP Gateway BDU. We are using some extra features here. Since we want to simplify things, and the image comes with some default addressing that we want to leverage, then we are specifying a couple of subnets in the S1 and the SGI ports to be used. So when we create the S1 and the SGI networks, because they are not pre-created in this example, they are created with a specific subnet through the use of IP profiles, and that IP profile is used in the VLD. And in that way, we can force the use of a specific IP address for those connection points. So the VM will get a specific IP address. How does it work? It's not by suppressing the HCP. I mean, the HCP is enabled, will be enabled in the subnets that this is created, that in the subnets were created by OSM. However, the neutron, in the case of OpenStack, the neutron IPAM service, which is embedded in the, we'll say in the DHCP server as well, that assigns the IP addresses, will assign this IP, and then it will deliver it through the HCP as usual. Okay. So this is the way it works. We don't need to remove, suppress, deactivate the HCP to get fixed IP addresses in our VMs. We just can assign the IP address that we want. So I'm going to copy this content inside the YAML file. So this file here. I'm going to copy exactly the same content. Okay. Perfect. Finally, I will validate the network service descriptor that I just created. Okay. And we'll get into the folder where my VNF and network service is described, and create the packages. There is an OSM package build command, but I'm still testing it. I'm not sure if it's ready for exposure yet because it's new. So I'm just using regular tab command to compress the folders. And we, at this point, are adding the VNF to our catalog in OSM and the network service. So it's ready. We finished the onboarding of the VNF when we reach this point, which takes us to the final step of launching the VNF. You may have noticed that we left some things parameterized. I mean, let's see. In the descriptor for day one, in the portion that includes a password, for example, we left password, we left SP gateway IP, we left HSS IP to be populated at instantiation time. So we can control the IP addresses that they will get. We also left RW management IP, but this is a OSM reserved name for populating the management IP address of the VDU. So those parameters that we provided, we will feed them during instantiation. Cloud init also supports parameterization. So in the cloud init file, that's why we included the password as well. Okay, so back to where we were, I'm creating a file that will feed the instantiation with the parameters that we want. So my file is going to be called params.yaml, that's an example. And the params I'm passing are these three: SP gateway IP address, HSS IP address, and the password that we want to use for both VDUs. And that's it. I'm passing that to the VNF, the only VNF we have. Remember that we don't have two VNFs. We have one VNF with two VDUs. And we can also control the descriptor from here. So we are taking the opportunity to feed, we are providing the IP address for the internal VLD network here. However, we are providing them to the charm section and to the VNF configuration section, to the primitives, but we have not told the system to apply these IP addresses through Neutron as well, so that Neutron, the networking component of OpenStack, can deliver those IP addresses through the HTTP. So at the internal connection points in the internal VLD of the VNF, we have to set the IP addresses as well. So this combination, I know we are kind of duplicating things, but on one side we need to tell the primitives which IP addresses are being assigned, and on the other side we need to tell the VLDs to assign these IP addresses. So this is the only way to, well, this is the easier way to exchange IP information between components and make our primitives aware of addressing. We are heading to better ways for the IP addressing detection between VNFs, but for now, this is I think the best one. Okay, so I have my parameters file ready, and I'm ready for instantiation. So I'm instantiating a Evolved Packet Core with a network service descriptor name. I'm passing a SSH key so that I can authenticate without password potentially, and configuring passing the config file that I just created. So this is equivalent to the config parameter without file and just passing the variables using brackets. It's the same thing, but it's easier to use a file. And the Vim account, of course. So I'm proceeding with launching the VNF. Now, inside the folder, I created the params file, and I'm going to specify the Vim account, which is in my case whitecloud 40. And I'm going to put my EPC name is EPC 40. That's it. It was launched. I can monitor it with OSM NSList. It's building. So if I go to OpenStack, I should see it, right? I should see the VMs being created. Or I can run OpenStack commands from here as well. Being built, HSS and SP gateway with the, I don't know if you noticed, but the management network that we are using in the network service is the OSM X here. So that's why the two management ports reached the external OSM X network. We have HSS, we have SP gateway, we have the internal VLD that interconnects them. VLD is virtual link descriptor, VL is virtual link. We have the SGI exposed, ready to connect it to internet. We have the S1 exposed here, ready to connect them to Node Bs and the user equipment. And that's it. It's instantiated. But the virtual machines are instantiated. We have to see if the charms are ready, because it's still building, right? So it must be working the charms. So for monitoring the charms, we have to switch to the model of UU that contains these charms, UU switch and the ID of the network service, and then run a UU status. So it is still installing the charm software. I know that with the new framework, this process is faster. With the reactive framework, it takes a little bit more time, but you have the commands there to monitor. And what it's doing is We can monitor with UUD backlog, it's installing some dependencies still on the LXC containers that will run the terms. Because every term is inside LXC container here. So it's almost ready. It's trying to get the IP addressing that was assigned. One is ready. The other one is ready. Okay, so it's verifying SSH credentials. Now HSS is being configured. SP gateway is being configured. Here the flag. Now HSS is restarting. And now it's finished, the HSS. Let's wait for the SP gateway. To see if there is some question. No. Still configuring the SP gateway. I'm debugging what's going inside. Oh, okay, it's ready because it's restarting the SP gateway now. Starting SP gateway, and now it's ready. So if I run OSM NSList, it's ready, it's configured. So to see if it was actually configured, we are going to access the elements, okay? So if I do a OSM VNF list, I should see the management IP address of the SP gateway, and I'm going to access it. Inserted the SSH key, so I access it without password. And now we noticed that it was filled with the Cloud Init hostname that we put. And there is a way to check if the HSS was integrated or not. Here, if you run this command, there is a stabilization between this element, which is the 10.06.15, and the remote element, which is the HSS, which is a 10.06.20. And of course, the files, HSS or mme.conf, if we see the files, they have been populated. Let's see where. Here. Listen on 10.06.15 and the HSS IP must be specified somewhere. Listen on 15, which is the local address, and connect to the peer 20, which is the HSS. So these files were populated previously with these parameters, HSS IP, SP gateway, and what we did was just to replace that. Okay, so our network service is ready. And if I run an action to add a static route, for example, it should work, right? So now, what static routes I have? I don't have a route for example, this Google DNS, which is just a sample route. So I will run the action from OSM using the name of my EPC, EPC40. This is a way of running primitives in OSM. In the dashboard, it can be done as well. So the VNF ID and the action name, which is add route, the parameters, external prefix and next hop, and the name of the network service. It ran the action. So now, if I go back to the gateway, and see the routes. Still not there. There it is. So it added the route. Okay, and last but not least, I should be able to see some monitoring, right? CPU on memory in Prometheus. I will open Prometheus. And I will open Grafana. Because both are connected somehow, right? Prometheus should, let me see CPU utilization, for example. No data yet. Let me see the memory. Oh yeah, we have memory. So there it is, memory of the SP gateway. And there is somebody else that already finished as well, EPC 16. Congratulations. And in Grafana, we have automated some things here. Let's see my project status. We have 2 VDUs. EPC 40 is up. We have 2 beams. And then if I look for my NS metrics, I have EPC 40 and EPC 16. EPC 40 has already the memory. And EPC 16 was probably launched before because it includes more metrics, and the CPU will start appearing soon.